Hi everyone, and welcome to today's webinar, Ability to Run Several Point Clouds at the Same Time. Let's start with this webinar officially. Just for your information, this webinar is going to be recorded, so you will be able to see the webinar again if you need to, or anything like that. The webinar duration should be about 45 minutes. And as I already mentioned before, feel free to set your question in the question box. If you have anyone questions, would be great if they're related to the topics we have today. But if they're also not so directly connected with this webinar, I would also love to answer your questions and help you with the photogrammetry issue or anything like that. And also maybe some suggestions for our next webinar. This one is actually our last webinar in 2021. Next year, we will start with new seasons, two live webinars per month, and try to bring you this technology closer to you, try to give you some ideas how to use this technology by your daily works or anything like that. And if you help us with selecting the topics where you have issues or anything like that, I think this would be even more interesting and even more effective. Some questions are already there, so I will answer them after the first part of the webinar. If there are some coming during the webinar, feel free to write them in question box. Okay, let's just do a short introduction about myself. So my name is Marco, and I'm part of a 3D survey team. Actually, by profession, I'm a land surveyor with more than 11 years of experience. Maybe some of you already know me. If not, I was working first 3 years as a traditional surveyor. I was doing topo maps, cadastral measurements, volume calculation measurements with the total station, GNSS measurements, and so on. Most of the time using AutoCAD and local surveying softwares. And then in 2013, we actually decided to start with photogrammetry. Until 2013, now already for 8 or 10 years, I'm working with the photogrammetry, with drones and 3D survey software. I'm actually product manager at 3D survey. And I also have some experience with drones because we manufactured and produced in 2016 so-called survey drone. At that time, there were no Phantoms and so on. So we need to build something from scratch and sell together with the software worldwide. Then we stop with production drones and focus purely on 3D survey software. I'm a trained drone pilot operator, so also if there are some questions related with the drone and operation and maybe best practice mapping or something like that, I have some experience and can answer also on those kind of questions. But main topic for today's webinar is how could you actually benefit with option to using more point clouds at the same time in a same project. As already probably some of you already know, 3D survey is not just a processing engine which produce super realistic point clouds, 3D models and orthophotos. It has also in addition option to do the vectorization with the integrated CAD tools to calculate all volumes, to generate profile lines, and a number of different functions are available. And this actually offers you also to timeline your projects. So to see the difference which was done on a construction site or open pit mine or anything like that. The software, it's pretty open, so it means you can load in number of different point clouds, a number of different data types, orthophotos, texture 3D mesh or anything like that in a single project, and you can actually observe them, inspect them, calculate the volume differences and so on. So our first point will be just a quick introduction. How can you inspect the difference between different measurements? How can you import the point clouds, and how can you play with this data? Then the second point will mainly focus in advanced analysis tools like volume calculation, profile line calculations. So when you're calculating out the volumes, you always compare two surfaces. And if you don't have ability to import just 2 point clouds inside, you are not able to calculate out volume differences actually. So this is also all the functionalities which are related to using more point clouds at the same time. And then at the end, even more advanced things. So we will show you how to combining different data type and creating the best possible digital terrain model. We will actually combining photogrammetry data with the LIDAR data. We all know that with the photogrammetry, if you have a tight forest with big trees and everything like that, it's hard to get the terrain points. And if you really need a terrain point, you need to combine it with a total station, measure some additional points, or if you have option, use the LiDAR data, which penetrate the vegetation area. And in case you get the terrain points, then you can combine those two different data types and calculate at the end a single surface out for volume calculation, for orthophoto calculation, or anything like that. So super short PowerPoint, and let's go directly into action with our first example, how to combine more point clouds. Ability to import more point clouds in the same project and observing them in the same time just offers you a timeline options where you can nicely inspect about the progress on construction site. Here we have a nice example of a small site. The dimension is 200 per 100 meters or something like that, where they actually remove the existing objects. They need to improve the stability of earth because it's a water area, and they would like to build a new shopping mall. So they start with the construction site, I think in September, and they plan to improve the stability in a 1 year period. And they decided to measure every month or every second month the terrain and observe how much material they actually put on it, how the terrain is moving because of weight of material and so on. And to have option to timeline the progress on construction site, you just need to have option to compare more point clouds in the same projects. And here we have already one point cloud which was calculated actually in September 2020. And what I can do in 3D survey is just go to point cloud, select cloud, and select my second point cloud which was calculated in November, for example, and imported in my main project where I would like to compare those results and do all the volume calculations and so on. So on the right side you can see list of point clouds. Now we have 2 point clouds here. The first one is September, the second one in November. You can already see in a 3D window those 2 point clouds, how they look like. If I deselect my first 1 point cloud, you can see on the second one the object was already removed. A lot of activities is going on my construction site, and there is already some progress which have been done. Okay, and this is just my second measurements. I can go the same way to point cloud, load, and select my third measurements, which was done actually in December. A couple of seconds to load the point cloud. And here we can see our third measurements in December. Again, if I deselect the November one, you will see just results from December. Again, a lot of activities is going on. a lot of construction things are happening, and this is just December. Let's go again to the point cloud load, and I still have April, June and August, so next year, and actually altogether 6 measurements. Now what I will do, I will select the first one, use the shift button on my keyboard and select June and August in addition, so I can actually select multiple point clouds and use open function to load them to 3D survey. And you can see on the progress side how the point clouds are adding, and right now I have in my list of point clouds all 6 point clouds. Just a quick trick with this square here, you can really quickly select all point clouds or deselect all point clouds. Okay, when you have selected all, if you just want to deselect single one, you can go and select single point cloud like that. Okay, now actually you can see in my projects 6 different point clouds measured in different time period, in September 2020, November 2020, December 2020, then in April, June and August. What you could do in addition, if you didn't load the point clouds in the correct row, you can actually move them up and down or something like that. So you have all those options. So if I correct this back, I just use the left mouse click on September and move it up right to the first position. Okay, need to do it again like so. And now again I need to do for the 0.3 December, let's move it here. Okay, now we have the correct row again, and which options are here actually open? Bounding box tool, it's usually really useful for that kind of observation. So if I go and use the right mouse click on a corner, I can actually rotate my bounding box. Then right mouse click on a plane and I can move it together like so. I'm moving the bounding box plane. The rotation is already perfect. This is my area of interest like so. Then other option is if I move it like so and zoom in, maybe also from the other side, you can already here from the bounding box see the progress which have been done on the construction site. So you can see the first measurements here, the second here, the third here, and so on. If you use the Control and right mouse click, you can actually slide with the bounding box down the construction site. If you would like to reset the bounding box, just click the reset view and you go out and see the complete results again here. Then to have ability to see the difference between 2 measurements, you just need to select, let's say I will first deselect all of them, and now I would like to compare the difference between the first one and the 5th one, for example. Okay, now I have just 2 point clouds on, and then even more visible, we add option to colorize the point cloud. By default you see actually default color, which is a realistic color, but if you click with the right mouse click on the point cloud name, you can go to point color, custom color, select your color you would like to have it and confirm it with OK, and the selected point cloud will be colored orange in my case, or red or something like that. And let's do this also for the 5th one. So right mouse click, point color, custom, and I will select this one as a green one. And now you can really nicely actually also see really quickly the difference between those two point clouds. Okay, right now we are in between. If you like to increase the render size from the point cloud to see it more clearer, you can use the slider for point render size. And then if we go further and calculate out meshes from those two point clouds, I would first suggest you to do the classification for both of them separately. Okay, so let's leave the first one selected and then select the fifth one and use the classification function. Classification parameters. So this is the classical work for classification. I select a single terrain point, click on next, the additional classification will be done. I click on finish. Okay, let me go and select the default color back to see where my classification was actually successful. So really nicely eliminate the objects, most of the machinery. I lose a bit of detail here, so I would like to add those few points additionally to my ground classes, because now all the red colored points are actually ground points, so we can see them here, and all the others are in unassigned class. Okay, and I would like to select also this part and move it to my ground class. So right click on ground, set this class to to ground class. And now this is actually my classification results. I'm super satisfied with this one. With clear I lose the color, and my point cloud September is ready for digital terrain calculation. Let's prepare the same one also the June. Let's put it back to the default color, classification on, the same way as before, confirming the parameters. I need to select one terrain point, next. Most of the terrain is classified, and here we can already see the classification results from the second point cloud. Let's just deselect the never classified and clear the selection, and here we can already see our two point clouds which are classified. And what's next? We can easily go to mesh, calculate new regular grid mesh. First we will do this for first measurements September. Click calculate, and this is our first mesh result. And if we would like to compare volumes, let's go back to point cloud tab, go again to mesh, calculate new regular grid mesh, and now we will decide it for our 5th June measurements, which is already classified. Grid cell size 0.5 meter, which is good enough for most cases for volume calculation. The new option optimize, that we create an optimal area for mesh calculation and smoothing cell size to minimum 1 cell to get the most accurate mesh out of it, mesh result. And here we can see already 2 of them. What we can do, the same as with the point cloud, we can actually select the first one and set some personal preset up. So I could edit like a hide map view with a shading option for the first mesh, and for the second one maybe wire show grid only. So number of different options are actually available. And then if I would like to calculate out maybe the volume difference between those two, I can just simply quickly go use my select function to select my area of interest, Right now I'm in between the volume difference and just click the calculate volume button from current selection, and the volume calculation is already in progress. Now we are comparing upper and lower surface from the first measurements and fifth measurements, and here we have the fill and cut volume and also the total volume results. So in my case we have 10,077 cubic meter of fill material and 2,253 cubic meters of cut material. So difference 1 to 5. Okay, and we can nicely see also this volume result visualized above our area of selection, and the same way we can also see it, the results in an ortho tab if we already have an orthophoto. Okay, this is all from first part, and let's go and see next what we can everything do also with the additional functions. Okay, we are back to our presentation, and we already have few questions available here, so I would like to quickly answer them and then continue with our topic. The first question: is there any future webinars for PPK use in 3D survey? Thank you for your suggestions. Maybe I can just briefly explain you how it works with the PPK. It's pretty simple than with the RTK, which has an integrated calculation. With the PPK, is the only difference that you need to have a log file, and when you import the images, you select the log file from the PPK and then continue the standard processing. If you like to know a bit more, you can contact us also via email and we can help you before the webinar already. Then there is another question connected with actually with the point clouds. So the question is, we had following issue: as I want to import E57 data from laser scanner, the coordinates were local, but last data it was correctly coordinates. Do you know about this problem by importing E57 point clouds? Yes, we know about those issues. It's not actually the 3D survey issue. It's more connected with the point cloud file formats. And if I go in 3D survey to the point cloud and click load, you can see we can load in number of different point clouds, and we can also save number of different point clouds. So LAS and LAS are pretty standard file formats. There are strictly rules how to use them, and that's why it works really nice. With the E57, it's a bit different. It's not well defined, and then every production have its own solution. So what would be possible would be that we can see your example and actually see if we can improve this. But otherwise, suggest you to use LAS file format. Okay, then second questions from Ugur. Will there be more formats supported for importing point cloud data? As you can see, we support already most standard file formats in 3D survey. Recap, so RCS and RCP are file formats actually from AutoCAD. This is their own file format. They don't want to share it with us or something like that, so it's impossible to integrate it in any other software. Maybe we will be in contact with them and ask them about it, but currently this is not possible. I know the workflow, it's kind of stupid because you need to have also recap if you like to import those data in AutoCAD, and you need to additionally buy some other software. But we support most of the other file formats which are available. So if those are not internal formats from some specific companies, then we support this definitely. Okay, so these were questions in this first part. If there are any more during the webinars, feel free, continue, set them in the question box. It's a live webinar, so join this opportunity. And let's continue with our webinar here. So I open now the same project, but I already have prepared all the other measurements. So I classified also the let's say the measurement 3, measurement 4, measurement 5, and measurement 6. So we have all point clouds already classified, and based on those measurements we also calculate all regular grid meshes for those point cloud. So as you have ability to load more point clouds, at the same time you have also ability to calculate more meshes in the same project. And you can see, for example, here 6 measurements, 6 regular grid meshes all together in a single window. And to visualize them more, I will use the same option as we used it before. So I will set the custom colors. The second one should be green. Let's set the third one really quickly, yellow. The fourth color, orange. The fifth one, custom color, let's take it blue. And let's leave the sixth one realistic color. Okay, now you can really nicely see here first where the first surface is, second surface, third, fourth, fifth, and sixth, and also the differences. If we are going to use also the bounding box, as you already see before, I will first rotate it to the right position, then I will move it like so. You can again really detailedly inspect about the differences in a different timeline actually. So if I move those fully together, you can really nicely see all those surfaces. And actually the red one was the first surface, the second one is green one, the third one is yellow one, then the fourth one it's orange, blue, and the realistic color actually. Okay, and again Control plus right mouse click and you are traveling down the project site and inspect about the progress on construction site. So it's similar as you would actually create cross sections or profile lines. Let's click on reset view and go back to point cloud and show you also how to calculate it profile lines for all those measurements. So I will just click here on list of point clouds to select all point clouds back. Those are all already classified, and then I just click a function, calculate profile. I would like to have profile every 10 meters. Go, let's say, 40 meters left and right. I could calculate profiles from the DXF line, but I don't have it here, so I will select profile definition line and just select my center line for cross section, and the software will immediately calculate it 16 profiles for each point cloud. Calculation still in progress. Few more seconds, and here we can actually see our 3D profiles in a point cloud tab. Let's just quickly deselect all point clouds. You can really nicely see all the graphs in a 3D. You can see those graphs in a mesh tab. You can see those graphs on Orthophoto where we generate them, and of course you can see also all those results in a profile tab. Okay, as you probably already know, the first one is our longitudinal profile points. So just a second, I'll turn off the anchor points. So the first one is longitudinal profile, and then here we have cross sections. And every line means different measurement. So the red one was the first one, then they remove some earth, we get a green, yellow, and so on. Okay, you can easily export those point clouds as a DXF or PDF and create report out of it or anything like that. If you need to improve the positions of the profile lines, you can also do it. So you just grab a point and move it or anything like that. But this is already described nicely in all other webinars, so with the profile line generation and so on. I would just like to give you an idea how nicely can you actually generate profile points from one point cloud, and if you represent this to your end customers, they can clearly see the progress on construction site. If you go, you can also generate those measurements report for the profile lines. So you just click generate, and the doc file will be generated. Let's have a quick view. So you can see the profile lines actually on the Orthophoto, a lot of points which are super important for position and accuracy, and then again the profile graphs for each graph separately. Okay, let's go back to software. So we see more point clouds in the same project. We see more meshes in the same project. Then the last step is more orthophotos in the same project. So as you can see it here, we have 6 of them. Let's turn maybe the profile points off. Again, with this list of profiles option, you can immediately deselect all of them and go back to Orthophoto. And then you can see I have here 6 Orthophoto. If I turn them off and I can select the first one, you see the first Orthophoto. Select the second one, we see the progress of a second one. The third one, a lot of snow already. The fourth one, winter ends, additional progress on construction site, and the fourth one already finished step, and the sixth one a bit additional work, and that's it. What can you do it here? You can see a specific point cloud. For example, if you would like to see the Orthophoto number 4 now, you can deselect here and turn it on like so. Or if you have all turned on, you can just move and grab the fourth one, the same as with the point cloud, and bring it total down, and then you see the Orthophoto 4. Or for example 1, you just bring it to the end step and you can observe it, the last Orthophoto. What's here super interesting, if you have a long road and you have more orthophotos, so let's say 1 kilometer of orthophoto, another 1 kilometer of orthophoto, and so on. And if you calculate them in a 3D survey, you get that transparency background. Then those orthophoto can fit nicely together, and you can also switch the row between them. If the one orthophoto is better than the other, you can do these manipulations and optimize your end results. Okay, this is more or less everything about this project I was like to sharing with you. Just kindly remember, if there are some questions connected to the current topic, that I can answer them at the end. Otherwise, I would like to go to my third point. So combining different data types. We have another interesting project. This project was actually done with the Metris 300 and P1 system from DJI. The area is about 500 per 400 meters. We have been flying this area on 70 meters, and as a result, we get a point cloud with a 77 million of points. I think those were just nadir cameras, but the result is already really nice, really good one. What we need to generate here is actually the best possible digital terrain model for later volume calculations. And because we have some additional vegetation on our area, and actually also, for example, here, which was a bit beside of our area, there is additional vegetation but we would still like to have some points. We actually combined this point cloud with the LIDAR data. Let me also go and load in the point cloud from the LIDAR. Actually, here we can see 2 blocks of LIDAR point cloud. I just select both of them, click on open. It's a ZLS file. In our country, we have free LIDAR data available every 5 years. They're scanning the complete area and update the terrain. And you see these points also here. What we can figure out really quickly, that in last 5 years there was some progress done actually on this site. As you can see, the bronze colors are here pretty higher in comparison with our measurements. So they grab quite a lot of material away here. But actually, if we look the areas covered with vegetation, those data are actually super fitting together. Okay, so probably if I would go to CAT, let's go to CAT and measure the delta height between 2 points. Now I need to be really carefully to select to snap on my LIDAR point and snap on photogrammetry point. I can see here we have a difference in this example for 9 centimeters, which is not that bad if you take in count that this is a complete LIDAR for a whole country. What I could do, I could actually improve the LIDAR position by selecting all and lower them for 9 centimeters, but let's leave this for our next webinar. What was my idea here is to show you how to combine those 2 data types and generate the best possible surface. And if I go back to point cloud tab and first just create my areas where I would like to combine those data, is I will go to CAT, create a new layer, let's say LIDAR area, and make the layer active. I'll use the red color, it's nicely visible, thickness to 3, and I will go and just draw really quickly my area of interest where I would like to add my LIDAR point cloud in addition. So this is my first closed polygon. Let's continue this part here. Okay, second closed polygon. What I need to be careful, I need to close my polyline. Okay, then I will go and select the area here. I'm doing this a bit faster because this is just a webinar presentation. For real, I will definitely take a bit time in addition to select this more carefully. And in this way, you can easily select your vegetation area, which you don't want to use from photogrammetry. And you can select your area in a LIDAR and then combine it. And let's do it like so. So let's say I have those three areas. Now I need to go back to point cloud. First, what I will need to do is actually I will classify my point cloud, photogrammetry point cloud, to eliminate all the vegetation because we need the terrain points and so on. Okay, the classification wizard comes up. Standard classification parameters, I will confirm them. Those are good enough for 95% of the project. I need to show one terrain point to my point cloud. We have here 77 million point clouds. That's why it takes a bit longer on my laptop computer. But nevertheless, we will have classified point clouds in a few seconds. Okay. Second step of classification. No, super. Let's click on finish and go to main window. And I successfully classified my photogrammetry point cloud. I just need to unselect unassigned, and those are my points from the photogrammetry. Let's see here if we need to delete few in addition. Clear. I think the vegetation was here nicely classified. I could also delete it maybe or something like that, but I think there's no need for because the classification was super successful, as we can see it here. And now I just need to add the LiDAR point clouds from this area. And how can I do it? I select the LiDAR, both on, and I would like to select those LiDAR with the help of my CAD lines. So with the new function, we have selection from CAD, and I just select a LiDAR LiDAR layer. And I'm calculating where those points are. We see we have those in a 2 point clouds, but we select them with the help of close polylines. And instead of delete selected, I will just click delete other. And actually, what I would like to do, I would like to merge my photogrammetry point cloud with LiDAR point cloud, which is like so. Let's put the LiDAR point cloud in height map view. What we can do in addition, we can actually define the point render size specifically, and I will increase it just for LiDAR to have the better visibility. Okay, and now what I need to do, I need to merge all those point clouds. So I used actually merge function, and I actually combined all point clouds together. Okay, because if I would like to generate a single surface, I need to have all points in a single point cloud. And you can see it here, point cloud plus TMR plus blah blah blah, and this is actually merge point cloud. I deselect all of them, also my CAD data, and now I have in the same point cloud actually LiDAR points and photogrammetry points. And what's next? Mesh, calculate new regular grid mesh, standard parameters, just use ground points, calculate out, and super quickly we have a perfect surface which is actually combined from LiDAR points and photogrammetry points. Okay, Also different view styles may be available, just to have a good idea. Okay. Cool. So this was most everything from today's webinar about using more point clouds at the same time. As you can see, you can play with a number of different options, how to combine different data types, how to calculate surfaces out of it in case you have this ability. So if there are any more questions available, this would be no good time. Let's just quickly check if we answer all of them. Thanks a lot. Okay, thank you. If there is anything else, feel free to contact us via email, call, or anything like that. If you would like to know more. Otherwise, thank you for listening today's webinar. This was last in this year, and see you on the next live webinar in next year. Okay, thank you for listening. Happy 3D surveying.